Hello everyone! Welcome to our experiment. I am Gideon Lumacan.
I'm Jazz Cortez.
I'm Salvador Vitalia.
And I'm Troy Lazaro, and we are here to conduct 3 experiments.
And so without further ado, let's start with our experiment. Let's go! For this experiment, you're gonna need a cup, an index card, and a coin. Once you have that, you're gonna put the glass on the table, put the index card on top of the glass, and put the coin on top of the index card. Once you're done with that, you're going to flick the index card like so. Let's watch that one more time. As you can see, there has been a reaction from the index card and from the coin. So with that, we can answer our questions. So for question number 1, what happens to the index card? As the index card was flicked, the index card reacted to an applied force higher than the weight of the coin, which then resulted in the index card flying away and rotating as it moves forward. Second question, what happens to the penny? So, when the index card was quickly flicked away, the coin drops due to the gravitational pull. However, unlike the card, it showed a clear downward motion. Number 3. How does this show that objects at rest want to stay at rest? The index card in the coin did not have any displacement or movement whatsoever until there was an external force that was applied to the index card, wherein the index card flies away while the coin falls down. Lastly, how does this demonstrate Newton's first law of motion? The coin in the drop test illustrates inertia as it remained at rest until an external force was applied to the card, responding to the gravitational force which caused the coin to move downward. This concludes, an object at rest will remain at rest unless there is an external force strong enough to move the object out of its place. For this next experiment, we're gonna need a straw, a golf ball, and a marble. For this one, put the marble on a surface, blow directly on the marble, and try on different angles. Next is to repeat it on a golf ball. Once you're done, we can now answer our question. When the marble is at rest, what happens? The marble remains at rest with no significant change in motion and displacement since there is no force to make the marble move. Number 2. When a force is applied in the opposite direction of the marble's velocity, what happens? The marble decelerates before accelerating to the direction of the applied opposite force. Since the applied force opposes the marble's motion, it causes the marble's speed to decrease and follows the direction of the greater force. Number 3. When a force is applied in the direction of the marble's velocity, what happens? The marble accelerates further as additional forces are applied in the same direction of the marble's motion, causing it to move faster. Number 4. How could you make the marble turn left or right? Applying enough force while aiming at different angles could change the direction of the marble's motion. Aiming to the right allows it to turn to the right, same as when you aim to the left. Lastly, number 5. Once the marble has velocity, what will happen if no further force is applied, and why? If the initial velocity is non-zero, the marble would continually move in the same direction at a constant speed since there are no further forces. It will continue to move unless acted upon by an external force. This tells us that an object will change in its motion in response to external forces acting upon an object. For this experiment, we used a straw, balloon, tape, and yarn. Start by attaching the string on both ends. Attach the straw to an inflated balloon, then attach it to the straw. And be ready for the release. Now that we're done, we can now answer our questions. What happened when the balloon was released? When the balloon was released, the air rushed out backward and the balloon moved forward along the string. Number 2. Why does the balloon rocket explain Newton's third law of motion? The balloon rocket demonstrates the third law by showing that the action of air rushing out backward creates an equal and opposite reaction, pushing the balloon forward. This illustrates the law's principle of action and reaction forces. This tells us that for every action, there is a reaction. And that's it for this video. Thank you for watching. I hope you enjoyed. Thank you. Bye-bye.